So think about what we know about inverses and inverse functions. Remember when we had an inverse function previously, what we did is we switched x and y, right? And then ultimately on earlier problems we solved for y, but we switched what was the x and what was the y. So I want you to think about that for a minute. I want you to notice that if we have this function y equals b to the x, that's the exponential form. The inverse function is this logarithmic function, which we're going to write as the form y is equal to log base b of x. And it might be helpful for you to kind of think about this. My last class period kind of asked about this because I hadn't really mentioned this previously, but I want you to think about, if you see that logarithmic form, if we were to rewrite that logarithmic form using exponential form, so I'm taking this logarithmic function, if I rewrite that using exponents, then that is saying b to the y is equal to x. So I think if you see that format, you kind of notice, okay, we've switched our x and y here, which is what we have to do when we're finding inverses. So it might be helpful, I don't know, to kind of make that connection and to write that in there. But in general, what you just have to remember is that if we are talking about a logarithm, whatever the base is, then the inverse function would have that same base. Okay, so we're going to look at some examples of that here for a sec. And actually, in some ways, this is kind of good and helpful because this is going to help us review, just very quickly, a cursory review of graphing exponential graphs. So y is equal to 3 to the x. If we were asked to graph that, think about what we would do. We would plug in, we would do a table of values. And remember, there were very specific x values I asked you to use. And if we plug 3 to the negative 1, we get 1/3. 3 to the 0 is 1. 3 to the first power is 3. So that's what the table of values looks like for our exponential graph. So to graph that, we'd be about right there, and there, and there, and we get this curve that looks about like that. And we get this asymptote here at y is equal to 0. So that's what our exponential function looks like. Okay. Questions on that? Hopefully that seems familiar to you. So I'm going to kind of color code this. This problem in particular, we've got a base of 3 for our exponential graph. So the inverse, the logarithmic function that we would say that corresponds to this would be y is equal to log base 3 of x. And so notice the question, since we know how to graph y equals 3 to the x, how could we find the graph of its inverse? Well, we're going to switch x and y, aren't we? So switch x and y. So we already have that table of values, so if we wanted to graph the logarithmic graph, we've just got to switch. What we see as our x's over here, we're going to rewrite as our y's. And what we see as our y's, we're going to put in the place of our x's. And we can graph that to get a feel for what that graph looks like. Let me fix that because that's looking way too messy. All right, so if I graph 1/3 negative 1 and 1 0 and 3 1, and that's what our logarithmic graph looks like. And actually it has an asymptote also at x is equal to 0. Okay. So notice what this reminder here says. Remember, inverses, they are reflected over the line y equals x. So I'm gonna draw in here. Oops. I'm gonna draw in that line y equals x just to kind of help you see. Do you notice between that blue graph and that purple graph, it looks like that's symmetric over that line. Okay, so that's showing us those are inverses of each other. visually. Okay? All right, I want to talk about some of the properties of each of these different graphs for a minute. But I want to find out if you've got any questions first. So, questions on anything so far? If you look on this next page, if you flip over, so I think kind of seeing it in the format that I wrote there on the board is helpful. But let's take a look here, because it's more or less giving you the same information, although I'm going to ask you to write it in a little bit differently in a couple places. It's telling you your domain and your range, and it's going to be the same whether you're looking at logarithmic growth or logarithmic decay. You're not going to see much about logarithmic decay. I'm going to kind of show you visually something here in just a second, but we're going to focus most of our attention on logarithmic growth, just for what it's worth. X-intercept, you know me, I'm going to want you to write that as a point rather than a just that number. But that's kind of the information that we summarized up there on the board also, right? Okay. Excuse me. All right. Exponential decay. I want you to think about what that graph looks like. So I'm just going to draw a little visual here. You don't have to draw this in here, but I just want you to kind of see. Think about what a graph of exponential decay would look like. It would be something like this, right? And so visually, I want you to notice that, yeah, if we draw this line y equals x, it's not quite as easy to see, especially because my sloppy curve there, you don't see it exactly, but hopefully you can kind of see visually that symmetry over that axis there, okay? Like I said, you don't see much with logarithmic decay, but I want you to be somewhat familiar with it. So logarithmic growth, you kind of want to have that visual in your mind. So just like some of these other graphs that you've learned, you should know what the square root graph looks like and the absolute value graph looks like. So try to get a visual of that logarithmic graph as well. I think that can be helpful. So the key points, remember we had those key points that we did in the logarithmic graph. Think about the fact that what that corresponds to in the exponential graph. So now in the logarithmic graph, remember it means we're switching these. So what was the negative 1, 0, 1 as x's becomes our negative 1, 0, 1 for our y's. And so this is just 1 over b and 1 and b are kind of our main points. So we're going to look at some specific examples of this and kind of talk through that, okay? Because that's just very general terms, isn't it? All right. Sorry, I apologize. What happened down here, this went to the next line. So that x plus 1 should really be over here. If you want to kind of cross that out and add it in over there. So we're going to look at these three different graphs. They're just a shift or a change of some kind from our basic parent graph of y equals log base 3 of x. So we're going to talk through those changes first, but then we're going to go through and actually kind of work through graphing these. So what's changing here in that first graph? What does the negative out front tell us is going to happen? Reflection over the x-axis. Good, Landon. So reflect over x-axis. What is this change telling us is happening, Ava? A plus 1 at the end like that, what does that do? It's not, if you notice, it's not in parentheses, it's kind of attached to the end. So that's actually going to be an up or a down. Good. So this is an up one, and this one here with it being attached to in the parentheses like that. Which direction is that one going, RJ? It's attached to the x. So remember, when it's attached to the x, we go opposite the direction it seems like it should go. We're going left or right. Be careful. I'm sorry? Left one. There you go. Okay. All right. Graphing a logarithmic graph is a little bit more involved than graphing exponential graphs because the first step is that we're going to create the table for our exponential graph that's the inverse. So we need to create a table. All of these are base 3, if you notice. We want to come up with what the table is for y equals 3 to the x. So we want to do our table of values for y equals 3 to the x. That's going to be first step. Okay, so this gives us a 1/3. 3 to the 0 is 1. 3 to the first is 3. So that's first step. Any logarithmic graph, we actually create the table for the inverse of that exponential. Okay, think of it as the parent graph, right, of the inverse. And now second step is that we want to flip those points. So we want to do the y equals log base 3 of x. So what does that mean we're going to do with our table? Just switch. What was our x is our y. What was our y becomes our x, right? So yeah, we're just switching our x's and y's. So now think about this. This is our table that we're going to use in order to actually graph these graphs. But now we've got all of these changes here that we said we've got to do. So if we're doing a change in this first graph, a reflection over the x-axis means we are going to multiply our y's by -1. So just the y values. So I'm going to rewrite that table. You may or may not have room for that, and I get it. It's tight space down there. So if you write big, you might not have room for this. But if I multiply -1 times -1, this becomes positive. That's 0, and 1 times -1 gives me -1. So this is my new graph. My new table that I'm going to use in order to graph this graph. So I'm going to go 1/3 and over 1. And then I'm going at 1, 0, and then 3, -1. And asymptote. So that looks a lot like the logarithmic decay now, doesn't it? So when you reflect it, it looks a lot like the logarithmic decay. So that's a reflection. That's what the negative does. Now I want you to see visuals of kind of what these look like again. You've seen kind of the basic graph, but let's kind of make those changes now. Okay, so we're going to use this table of values from over here, this same table, only now we decided we need to shift up 1 unit. So remember when we did the exponential graphs, we did this similarly too, where we kind of drew in a new hash mark. We put in a new starting condition or a new starting place with our shift. And then we decided, okay, now from there, we're going to graph these points. So from my new shifted starting position, I want to graph these points. So I want to go over 1/3 and down 1. I want to go right 1. And I'm doing all of this from that new shifted position. And then 1, 2, 3, and up 1. So x is equal to 0. Guys, notice no change in asymptote there.
Why is x equal to 0 again?
That's for our asymptote, because nothing it hasn't gotten shifted off of the origin there, or that y-axis. Okay? But for this next one, if you notice, we're supposed to shift left 1. So if you think about it, that means we are shifting off that main spot, so our asymptote is going to change. So from that new location, we're going to graph, guys, these same points over here. So we're gonna use these points still. And so from our new spot, we're gonna go right 1/3 and down 1, right 1, and then 1, 2, 3, up 1. And we have a new asymptote here, don't we? At x equals -1. So think about that. It should make sense to you actually if you think about it. That
Sorry, I think I already said this, but why is the cycling and why is it not x equals 1?
we're not shifting left or right. We're only shifting up.
Oh.
So if we only shift up or down, no, it's a great question. If we're only shifting up or down for these, our asymptote won't change. Only if we're shifting left and right. Whereas, go back and think about our exponential graphs, right? On our exponential graphs, if we shifted up or down, that's when our asymptote changed. If we shift just left or right, it didn't switch. So hopefully that connection makes sense too. Okay? Questions? We're going to look at some other a few other examples. We are not going to do that entire next page, so don't freak out when you flip to the next page and you see like a gazillion graphs there. We're not going to do all of those. We're going to just talk through kind of some of those, okay? All right, quick brain break. I'm going to grab a sip of water. Yeah. Okay, so I want you to notice we have got a page here of a whole bunch of different bases and these logarithms, right? So we're going to go through a few of these examples. We're not going to go through all of these. We're not going to draw out all of these. If you want to look, I will have these notes posted later so you can, if you wanted to try some of these on your own, just for more practice, you could. I'll have this posted online, okay? First step though, let's look at these. Whoops. What am I doing here? These first two, if you notice the base is base 4 on the left, base 5 on the right. We've got some other stuff to deal with there. So first step is we need to come up with the table for, remember the inverse, so y equals 4 to the x. And the table for this one, we're going to do y is equal to 5 to the x. And this table here, we're going to do, for all three of those going across, we're going to do y is equal to 2 to the x. So go ahead and complete those tables. And then we're going to talk about flipping and actually graphing, okay? Yeah, good point. So we're not going to graph the exponential there. We're using that table. And now, to actually graph y equals log base 4 of x, we're going to switch the table. So -1, 0, 1, and then we got the 1/4 and the 1 and the 4. So guys, I hope you realize that the reason why I'm going to expect to see the table, these graphs, they kind of start, they're really close. These points are really close together. They're really tight. So that's part of the reason why I expect you to show me the table, is so that you know, you're showing me you know and understand where these points really should be. So this is at 1/4 -1. Yikes, it's bouncing around all over the place. 1, 0, and then 4, 1. There were no shifts or changes or anything on that. So this one's pretty straightforward.
Wait, so why do you switch it again? Just because it's a log?
Yep, because originally we're doing the exponential graph, but we want to graph the logarithmic graph, which is the inverse. So we're switching the x and the y. So yeah, you need those two tables, remember. Okay? All right, let's look at, I'm going to ask you guys to do that, one of those. So let's do I've got my table there for y equals 5 to the x. So to get the table for y is equal to log base 5 of x, I'm switching my x and y. Right? But I've got some other stuff going on here also. So, Gwyneth, what is that telling us we're going to do for shifts? Right 1 up 2. There you go. Okay, so we want to go right 1 up 2, and that's where I'm drawing kind of my new starting position, my new hash mark that I want to use as my guide. And then I am going to graph just barely over and down 1, and then over 1, and then 1, 2, 3, 4, 5, up 1 to get the shape of that curve. And notice asymptote changed here to x is equal to 1. So guys, take a look real quick, and then I'm going to ask you to do one of these here. But hopefully, it's pretty obvious. Like the asymptote for this one was x is equal to 1. What's the asymptote? What would the asymptote be for this one? The change in the asymptote. Juan, what would that one be for number 2 here, right there in the middle?
Right, 2 down 2.
Okay, but so where would the asymptote be? What would the equation for the asymptote be? Careful. We're switching the sign, right? Let's go back and look. On this one, we went right 1. We had x minus 1 in the parentheses, but our asymptote ended up being at x equals 1. So x equals, if we have x minus 2 there in that parentheses, what's our asymptote going to be? Positive 2, so x equals 2. What about this one, Drew? This third one?
It would be -3.
X is equal to -3, right? So it's pretty, and what would this one be? We've got one other one. Ava, what would that one be?
Wait, sorry.
X equals 1. Okay, so wherever if there's a number attached to the x inside that parentheses, that's shifting it to tell us where our new asymptote is. Why don't you guys try, did you get the table here for y equals 2 to the x, hopefully? So try, we need to switch it, so y is equal to log base 2 of x. So we're switching our x and y. I know this seems to get tedious, but it really is helpful and important to kind of practice writing out that table, making sure you're comfortable with what those points are. And I'm going to expect to see them on the quiz and on the test, just so that you can show me you know where those points are. So why don't you try this one. Try number 3 yourself. So we have our new table that we're going to use, and we've got these shifts. So try that one. Okay, so our log base 2 of x table is right here. For this graph, think about what that's saying we're going to do. We're shifting left 3 and down 1. Here's my new starting position, my new hash mark that I want to start from. And I'm just graphing those points as if this is my new origin. And that gives us that shape for that graph. Okay? All right. We're not going to graph these down below or on the next page, but I want to point out a couple of things to you about them. Notice this graph, there is no base that's written there. So remember, the first step is that we do our table and we do y is equal to something to the x power. So you have to remember, what's the base understood to be there? 10. Yes, we have 10 fingers. So yeah, we are common log is base 10. So the table that you would do would need to have y is equal to 10 to the x, right? And then you would switch it. So y is equal to log base 10 of x. Someone asked me earlier today how you say 10 in Spanish. They didn't remember, so that's why I was saying that. Okay, that's common logs. Here, remember, ln means we're talking base e. So if you're asked to do an ln graph, the first step is going to be doing your table for y is equal to e to the x. So let me refresh your memory about that real quick. So e to the -1, we get 1 over e. E to the 0 is 1, and then we get e. Remember, E is approximately 2.71828. And then the other thing to remember that we talked about is in terms of graphing this, we don't know how to graph 1 over E, but we know that that's approximately equal to 1/3. So when you're graphing, you can think of that as that it's approximately 1/3. Okay, so to graph this logarithmic, y equals log base E of x, we're switching. And that's what we would graph, is this here.
Do you just graph that whole number?
You're not gonna, I mean, how do we graph that? I'm glad you asked about that. Think about that. We said we would graph approximately 1/3, so that's where 1/3 -1 is, and then 1, 0. The way to show this E comma 1, Luca, is just make sure when you're graphing this, it's not quite at 3. Right? So kind of over exaggerate that point, over accentuate that point to show me that you know it's not quite at 3. It's close, but not exactly.
But when we're writing out our columns, we have to write out the full number. If I don't remember,
You can put E there also, but I wanted the number there because I want you remembering that it's approximately 3. Okay? All right.